Okay, guys, so we're looking at this question, which is a pretty tough question, especially at this stage of your lives. And the question said, the random variable x has a normal distribution with a mean of 200 and a standard deviation of 50. Find the value of c if it is given that the probability that x is bigger than c, given that x is bigger than 280, is equal to 0.625. Okay, so first of all, okay, remember in this is given. So we're given x is bigger than 280. Okay, so we're only working with the x scores that are bigger than 280. So if I looked at the x scores that are bigger than 280, and I had this, you're not going to have to draw this. I'm trying to explain something. Okay, if you're only looking at the scores that are bigger than 280, that's our sample space now. All scores that are bigger than 280. So this is all scores bigger than 280 in this diagram over here. So our most bottom value is 280 on this normal distribution. If x is bigger than 280, then the probability that x, given that x is bigger than c, is equal to 0.625. So this is if you're only looking at scores. And what is that? In other words, that the scores between 280 and c, okay, if x is bigger than 280, there's still 0.3, the probability that, okay, there is going to be 0.375. Okay, so in other words, c must be to the right of 280 because there are some scores which are bigger than 280 and smaller than c. Okay, so c has got to be, because this probability here exists, is not equal to, this probability over here is not equal to 1, okay, then it's got to be to the right. If I had this situation over here, okay, and they told us, given, this has happened already, x is bigger than, I'm only looking at scores here once again that are bigger than 280. Given that x is bigger than 280, okay, and they told us that probability, that what's the probability of x being equal to c is equal to 1, then c would be to the left of 280. C would be over here, because it's absolutely certain in that situation that if x is bigger than 280, which is where we started, then it has to be, x must be bigger than c. Okay, that would be certain that x is bigger than c. So if that was equal to 1, c would be to the left on your diagram. So that actual diagram you've got to plot, okay, c is got to be to the right of 280, because otherwise that probability, this probability over here, okay, this probability here would be equal to 1 if it was to the left. So c to the right of 280, okay? And the question is, I've got to figure out c. Now this is a conditional probability question. So we've established c is to the right. And if it's a conditional probability question, we've got this formula, okay, that the probability of a given b is equal to the probability of A and B over the probability of B. So in this, for this particular question, we know that the probability of X given C would be equal to that. Okay, X and C and over the probability of X is bigger than 280. Okay, now it's probably where biggest mistake, a lot of you got to that stage over there, and then it all got confused. The trick is this. If we look at this original diagram over here, okay, this diagram here, this probability that X is bigger than C and X is 280. Okay, so this, I'm looking at this bit over here. Where is that on this diagram over here? Well, two things have to happen. X has to be bigger than C and X has to be bigger than 280. Where is that? If both conditions have to be met, in other words, X has to be bigger than 280 and X has to be bigger than C. Where do both conditions get met? Well, this, what I'm shading in here, okay, that is the only region, okay, this region over here that I'm shading in green is the same, is that region over here. Those are the things that are bigger than C, and both things have to happen and are bigger than 280. So in other words, you can see there, the probability that X is bigger than C and X is bigger than 280 is exactly the same thing as the probability that X is bigger than C. So this was a core thing that people missed. Okay, that over here, Okay. This is the main idea people missed. That x is bigger than c and 280 is exactly the same thing as the probability that x is bigger than c. So if I now look at this formula over here, I can rewrite it as that, because this and this are the same thing. So now I get the probability that x is bigger than c, given x is 280, is probability x is bigger than c over the probability x is bigger than 280. But I know I was told in the question that the probability that x is bigger than c is equal to 0.625. So, in other words, 0.625 is equal to this whole thing over here, the probability that x is bigger than c, given that x over x is bigger than 280. Now, to work out the probability that x is bigger than 280, okay, I'm going to go back. That's just a normal distribution question. So if I look over here, I'm going to go back to this diagram here. The probability that x is bigger than 280, I'm looking for this region shaded in red over here. Okay, so to work that probability out, okay, I've got to work out the probability x is bigger than 280. I'd like you to start setting up your notation like I'm doing here on the left. Okay, so x is bigger than 280. Well, z is equal to x minus mu over sigma. So the probability x is bigger than 280, okay, is the same thing as the probability that z is bigger than, subbing into that formula, x minus mu, 280 minus 200 over 50, because the standard deviation is 50. So we're looking for, in other words, that the probability, what is the probability that z is bigger than 1,6, right? So 1,6 is associated with an area of 280. So to figure out the probability that z is bigger than 1,6, I'm going to go find this area here in blue. That's what my table is going to give you. In your table, so you're going to look up h of 1,6, and h of 1,6 is equal to 0,4452. That's h of 1,6. Okay, so that area there is 0,4452. Okay, so in other words, the area I want, this area shaded in red, which is the probability that x is bigger than 280, okay, is going to be equal to 0,5 minus 0,4452. Okay, you've got to cut out that area that I want. So in other words, the probability that x is bigger than c, bigger than 280, and a lot of you got this, but is equal to 0,0548. Okay, so if I go back to this formula over here, okay, I know now that the probability that x is bigger than 280, this bit over here, is equal to 0,04548. So if I times out, I end up, the probability that x is bigger than c, okay, times those together, is equal to 0,04343. Right, but now the question was, go solve for c. Okay, so if I draw up a new diagram, okay, for this data, okay, I've got mu was equal to 200, so z is 0 there. Okay, I'm told that the probability that x is bigger than c is 0,00343. So that's that area over there, if that is c over there. Okay, so I've got to go find the z score associated with c. Okay, so if I go to the table is going to give me this area in green over here. So the area h of zc, okay, is going to be equal to, what your table is going to give you is going to be 0,5 minus this 0,0343. So h of the z, okay, value of c is 0,4657. Okay, so that's this area in green over here. Now you go to your table and you look up an area of 0,4657, okay, and you find the associated z score, and you should get the associated z score is equal to 1,82 over here. Okay, so the last thing left to do is to find the value of c. Okay, so to find the value of c, we're going to use z is equal to x minus mu over sigma. So x is equal to z sigma plus mu. Okay, the z score for c is 1,82. So 1,82 times 50 plus 200 will be C. So C must be equal to 291. Tough question. Biggest problem was this over here that you didn't recognize, that the probability X is bigger than C and X is bigger than 280. This thing over here was the biggest problem. Is exactly the same thing in this scenario as the probability that X is bigger than C. Hope that helps.